Bismillahirrahmanirrahim, dear students of basic electronics. Today I am here to discuss with you another type of field effect transistors, that is P-channel J.F.E.T. J.F.E.T, as you know, that stands for junction field effect transistors, and we will discuss on such type of field effect transistors, how they work and what are their functionalities. And right here, we'll come soon towards definition. As per definition, it states that such type of field effect transistor which have junction between gate and channel, while current is flowing through it due to holes. The basic thing is that its construction is very different. If we come towards its direction, here we have only this part is basically the internal construction of this symbolic configuration, which is basically field effect transistor. In field effect transistors, the arrow of gate is coming outside, while drain and source are the two terminals. Basically, there are three terminals: gate, source, and drain. And the internal construction is totally different from N-channel J.F.E.T, which have a big substrate, P-type semiconductor material over here, while N-channel is connected towards the gate, and P-channel is basically connected with drain and source. So P-type substrate have a large part, so the only thing that can easily flow the electrons is holes over here. And in N-channel J.F.E.T, we found that electron flows due to the electrons. But right over here, electrons, the current is flowing due to conventional current, that is basically due to the holes. So we come towards the function. When positive terminal of a battery is connected with source, here the positive terminal of battery is connected with the source, and negative terminal of battery is connected with drain. The negative terminal of the battery is connected with the drain. Then positive terminal repels holes from source. Then positive terminal repels the holes towards drain, and the negative terminal connected with the drain attracts those electrons, those holes towards it, and simply the current flows through this channel path from source to drain. If we come towards take another view, we can have that when if we connect the opposite proportions, means that if positive, not here negative, not negative over here, if positive terminal is connected with drain and negative terminal is connected with source, this means that the opposite connection of the battery. The positive terminal is connected with the source, with the drain, and positive terminal, negative terminal is connected with the source. We opposite the terminal connections. Then automatically, what happens that gate and source junction will reverse bias. As a result, the depletion layer will increase and channel width will decrease. As a result, a minimum level of current will flow through it and the current will minimize to its lower position. So this is how it works. Now we come towards the characteristics. We will discuss those currents specifically on VDS because we are taking current from source to drain. So VDS is over here, and output current is basically adding drain current because drain is we are using drain as an output terminal. So when we apply a zero level current, VGS is equal to plus 0 milliamperes, and as a part by the decrease of the current from the forward biasing of the current from drain source to drain, we get positive 1 and positive 2. At the end, it comes to the lower point, that is 0. This is basically how the characteristic curve is working. Only only it works, this characteristic term works when we have a positive terminal connection with the source and negative terminal connection with the drain. It will become, it will work very function, its function will be very much fruitful and very will be result oriented. And while when we oppose those terminals, we have a zero level current over here. The current will minimize its level and no current will flow through it. Simply as if I go to a comparison with the transistor, common emitter transistor over here, what I found over here, I am finding that if we discuss about the PNP transistors or and P-channel FET working, there is not a single difference of connection or biasing over here. Right now we are forward biasing this part and reverse biasing this part. And in N channel and in PNP transistors, we also forward bias this forward bias the collector and the emitter. So more of most more similar in connections and functions with the PNP transistor operational amplifier, PNP amplifier, transistor amplifier. While FET is basically we are using FET due to its fast switching more than transistors. I'm hopeful that you have understand over today's lecture on P-channel FET, and if you found any kind of problems, you may ask me on my WhatsApp number. Stay safe, stay home, and happy winter season. Thank you so much.